Hey guys, I'm going to take a look at the Geometry Chapter 3 review guide and the content that's in that. This is just reviewing the sections or what things that you need to focus on in each section from Chapter 3. So 3.1, it says parallel lines and transversals. And so this is where we talked about having lines. So two lines. Doesn't have to be parallel, could be, but does not have to be. So I'm going to draw two lines that are not parallel. And then this is the transversal, the line that goes through two or more lines. And then you can see that we make 8 angles here when we have two lines cut by a transversal. And depending on where the angles are located, you have interior, exterior, consecutive interior, alternate exterior, and corresponding angles. So you need to know about all of those. The other thing we talked about briefly was parallel lines in this section. And parallel lines are two lines that never intersect. And we indicate those usually by a little triangle or an arrow somewhere in the middle or somewhere on the pair of parallel lines, and so that tells me that I have parallel lines. On 3.2, we talk specifically about what happens when our two lines that we're cutting with a transversal are parallel lines. So we have a line, or we have two lines. We're going to say that they're parallel. So this is also a way to indicate that they're parallel. And then cut by a transversal. And so we find out that we have either congruent angles or supplementary angles when we have two parallel lines cut by a transversal. These are our theorems. It says if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So an example in our picture would be angles 1 and 5 would be corresponding angles and they would be congruent. Then I have each pair of alternate interior angles is congruent. Our alternate interior angle example would be 3 and 6. So if two parallel lines are cut by a transversal, alternate interior angles are congruent. The third one, if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So that would be, an example would be angle 3 and 5 would be consecutive interior angles. And so their measurement would add up to 180. And then the fourth one, if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And an example of that would be angles 1 and 8 or 2 and 7. So they would be congruent. The only one that gives me supplementary angles is the consecutive interior angles. Okay, in 3.3, we talked about slope, and we've got a couple of ways of finding slope. One is graphically. And so if I had a coordinate plane here, and I had a line, let's say going through these 2 points here, then I could find the slope by seeing how much I go up and over. So that's the rise over run, just by looking at the graph. The other way I can find slope is by using the equation y2 minus y1 over x2 minus x1. And so in this case, our coordinates are 0, 0, and maybe 4, 3. And so those would be our x1, y1, x2, y2 that we would substitute into the equation. Doesn't matter which one's 0.1 or 0.2. Then we have different equations of lines. We first had standard form and what that looks like. Then we had slope-intercept form, y equals mx plus b, m is the slope, and b is your y-intercept. Then we had point-slope form. So given a point and a slope, we would use that typically to either write it in slope-intercept form so that it's more easily graphed, or we can put it in standard form. And then what's the equation for a vertical line or a horizontal line? Vertical lines go up and down, and horizontal lines go left to right. In 3.5, this was the reverse of the 3.2 theorems that we had. So instead of knowing that we have parallel lines ahead of time and then saying our angles are congruent, we're trying to prove that they're parallel. And so it says we have two lines cut by a transversal. And for this, I don't have any parallel markers at first. So I don't know that the angles or the lines are parallel. But if I were looking at the first theorem, it says if two lines in a plane are cut by a transversal so that one of the following is true, then the two lines are parallel. So if, and in this case I have, here's my angles again. Angle 1 and 5 are corresponding angles. So if I say that those corresponding angles are congruent, which those markers say that they are, then I know that my lines, in this case we'll call it lines A and B, would have to be parallel. But I don't know that first. I know that the angles are congruent, and then I can say the lines are parallel. Another one that I had was if I have two lines cut by a transversal and alternate exterior angles are congruent, then my two lines are parallel. If two lines are cut by a transversal and alternate interior angles are congruent, then my lines are parallel. And if a pair of consecutive interior angles are supplementary, then my lines are parallel. So I only have to have one of those in order to show that my lines are parallel. All right, for the last lesson, we had perpendiculars and distance. And it's basically how do we go from a point to a line? So we have a line and we have a point. In order to find the distance from that point to that line, we need to draw a segment that is perpendicular to the line that we're going to. The shortest path from the point to the line is considered the distance. So we would want to know, well, what is this point? If we're looking on a coordinate plane, what is the point that we're given? Put some coordinates here. And then we would use the distance formula to find that distance. If we have two parallel lines, okay, and we want to find the distance between those, what I would do is I would indicate a point here, find the slope of the perpendicular line, or the parallel line, and then figure out what a line that's perpendicular to it would have to be so that I can draw that line and see where it intersects with my parallel line. Then I've got 2 points, x1, y1, and x2, y2, that I can again use the distance formula to find out the distance between those two parallel lines. You definitely want to be able to use the distance formula. Okay, best of luck. Do the practice problems and check your answers. And if you have any questions, feel free to message me through Canvas or come by my room and see me during school hours. Thank you.